So here we have the problem. Pause this video if you need to. So I'm just going to move on to the solution. So at first it seems like we're faced with a rather daunting task. So we have a cube, and then we're being asked to find the flux through one of the surface. So using conventional calculus methods, this is going to be pretty messy. So you need to find the flux through this surface, you need to find the normal, you need to vary the distance from the surface to the charge, so the calculations are going to get really messy. So the trick to get ourselves, to save ourselves all that effort, is to consider this configuration here. So instead of one cube, I have 8 cubes here, and with the charge being in the center. And because you see that all of these sides are all symmetrical, you can expect that the flux through each and every single one of these surfaces is going to be the same. So we're being asked to find the flux through one of these surfaces. So if I can find the flux through this entire big gigantic cube, I can just divide it by the total number of these smaller surfaces, which is what I'm trying to find. And if you'll count, you can see that there are actually 24 of them. So it's just 6 times 4. So we have actually 24 of these small squares. So if we find the flux through this entire cube and then divide it, so the entire flux of the entire cube, and then divide it by 24, this is going to be the answer that we want. So the flux through one of these smaller surfaces. So the problem is to find this flux here, so the flux through the entire cube. So how do we find that? So the trick is to observe that the cube is actually a closed surface, so we can actually apply Gauss's law. So the flux through the entire cube, this is going to be equal to the total number of charge enclosed by the surface divided by epsilon. And you see that the total amount of charge enclosed by this cube, it's only this. There's only one point of charge inside. So that's just Q divided by epsilon. And so that's it. That is the flux of the entire cube. So we found this expression here. So by dividing it by 24, we've essentially found the flux through this smaller surface. And so our final answer is, so the flux through this surface is actually equal to Q divided by 24 epsilon. So by considering this configuration here, we've saved ourselves a lot of cumbersome calculations. So this is our answer.